Hi everybody. So today I'd like to talk to you all about electricity. And in particular, I'd like to talk to you about the relevant aspects needed to understand and build some basic circuits. And eventually we'll talk about some of these circuits and some of the things you can do with these circuits, and as well as the Arduino microcontroller and some neat things you can do with that. So to start off our discussion of electricity, it's probably first helpful to think about different materials and what they're made of. So, for instance, if you think about a piece of copper, copper is used in a lot of electrical components and a lot of electrical devices. What it's made up of is a bunch of copper atoms. Now, inside of the atom, there are several different smaller particles. For instance, there's protons, which live in the nucleus of the atom, and I'll draw like this with the plus sign, and they get the plus sign because they have what we call positive charge, and that's an intrinsic property of protons. Now, in addition to the protons, there's also neutrons in the nucleus of the atom. And the neutrons I'll draw just with these circles without anything inside of them because they're neutral. They have no charge. And together the protons and the neutrons are bound up together in the nucleus of the atom. There's a third particle contained in the atoms, which is the electrons. And I'll draw the electrons with a negative sign inside of a circle. And this is because the electrons are negatively charged, so it's the opposite charge of the protons. Now, the electrons, they exist outside of the nucleus of the atom, and they follow some complex behavior dictated by quantum mechanics, and it's not really useful or necessary at this point to get into that behavior. For our purposes, though, we can just think about them as kind of going around the nucleus. It's not completely accurate, but for our purposes, that's good enough. The other thing that's important to recognize about most atoms is that they have the same number of protons and electrons. So, and since the protons have a positive charge and the electrons have a negative charge and they have the same magnitude of charge, 2 protons and 2 electrons is going to make the atom overall neutral and not have any charge at all. And different atoms, they have different numbers of protons and electrons and neutrons, but generally it's the case that the number of protons is the same as the number of electrons. And this is why most things are electrically neutral. So a block of wood or a piece of copper, anything really, has lots and lots of charges in it, but they exist in equal numbers of positive and negatives, or very close to equal numbers of positive and negative charges. And therefore, the material has no net overall charge. Now, let's think about the interactions that these particles have between each other. So if you had 2 protons, for instance, that were near each other, they would feel a force between them. And since they're both of the same charge, this would be a repulsive charge. You could do the same thing with the electrons, and 2 electrons next to each other would also repel. Now, if you had an electron and a proton together, now these are opposites, and they would feel an attractive force. So the one way to think about this is sort of the so-called opposites attract and like repel. This basic interaction is extremely important in understanding some of the basics of electricity and how circuits work. One other thing that's important to talk about when we're thinking about atoms and materials and their electrical properties is there's definitely a difference between copper and wood, for instance. So copper is a metal, and like most metals, it's an electrical conductor. And what we mean by that is that it can, the electrons in the copper are free to move around. So while most of the electrons in the copper atom are sort of bound to a particular atom, some of them can move around and jump to different atoms. And so the material can conduct electrons or conduct electricity. Other materials like wood or plastic or glass are insulators, and those materials, all the electrons are stuck to their atom and they're unable to move around, and so we talk about those as being insulators. They don't allow electricity or electrons to move around freely. Now, in pretty much all cases, the protons are fixed in place. So when we think about charges moving, we're almost always talking about the electrons moving around. So now let's see if we can take these different ideas of the positive and negative charges, these ideas of conductors versus insulators, and let's see if we can combine some of these ideas and talk about sort of a basic circuit and some of these circuit properties. So the first electrical component, or the first electrical device I want to talk about is a battery. And let me draw out just a sketch of a simple 9-volt battery. So this is a battery I'm sure you guys have all seen before. And you'll notice that on most batteries, they'll label a positive terminal and a negative terminal. And what's going on here is through various chemical reactions going on inside the battery, there are a bunch of extra positive charges on the positive terminal and a bunch of extra negative charges on the negative terminal. Now, these two terminals are separated by air, and air is an insulator, so the charges cannot move across the terminals of the battery when it's normally just sitting there unconnected from things. But if you were to take a wire, like a piece of copper, which is what a lot of wires are made of, and connect these together, so this is our wire, then you would allow some of these positive charges to move through the wire, or some of these negative charges to move through the wire. Now, as I mentioned before, in actuality, it's the negative charges that are doing the moving. But if negative charges move this way, that's the same thing as if positive charges were actually moving in the other direction. It doesn't really matter which way you look at it. And typically, we think about the positive charges are moving around. So if we hook the wire up like this, even though it is electrons moving around like this, I might talk about it as if positive charges are moving around in that direction. And the movement of those positive charges is what we would call current. So I'll draw that with an arrow. And typically we label current with the lowercase letter I. So I is the current, and current is the flow of charge. And a lot of times we think about, like I said, the flow of positive charges, which is what we call the conventional current. So that's why the arrow points in this direction. That's the flow of positive charges, or the conventional current flow. Now, the current through this wire doesn't flow completely unimpeded or without any kind of resistance. There's actually some resistance in this wire. The electrons, they interact with the wire, or the charges interact with the wire as they move around inside it. And so there is some resistance to that flow. And a lot of times we represent the resistance with a squiggly symbol. So if I were to break that wire like that and put a squiggle in there, that would be representing the resistance, which we write with uppercase R for the resistance. Now, what we haven't talked about is this voltage here, this 9 volts of the battery. Now, voltage is created whenever you separate positive and negative charges like you do in the terminals of a battery. And voltage acts in a sense like an electrical pressure. it's pushing the charges to try to get them to reunite with the positive and the negatives to reunite. Now normally that can't happen if there's nothing connected to the battery, but of course, like we talked about, when you hook up the wire, then they're able to reconnect. And the voltage is what's pushing them through to make that reconnection of the positive and negative charges. And so 9 volts, that's a characterization of how much voltage or how hard they're pushing to get back together. Now, if we wanted to combine these 3 ideas of current, voltage, and resistance, we can do that with a mathematical formula known as Ohm's law. So if we think about the current is created by the voltage V. So the more voltage, the harder we push, the more current's going to flow. And it's impeded by the resistance. So it's inversely proportional to the resistance. So the more resistance there is, the less current will flow through the circuit. And this relationship is what's known as Ohm's law. And this is an extremely important, extremely fundamental principle when you're talking about circuits. And you can get very, very far just with Ohm's law. So this puts us in a place where we can now have, really, this is all the basics we need to start doing some things with circuits, start building some circuits, and seeing how they work. So just as a refresher, remember all materials are made up of atoms, which consist of protons, neutrons, and electrons. The neutrons are neutral, so we don't really worry about those from a circuit standpoint. The protons are positive, the electrons are negative. Generally, atoms have both equal numbers of positive and negative charges, so they're generally neutral. Some materials, like metals, the charges can move around. We call those conductors. Other materials, like wood, plastic, and glass, are insulators, and they prevent the charges from moving around inside them. Components like batteries produce voltages, which can then push charges through conductors like wires, creating current, which is the flow of charge through the circuit. So in some of the next videos, we'll see how we can use this information and build some neat little circuits.